Good morning. I wanted to give you a quick video on how to use tables to decide if a function is linear, quadratic, or exponential. This is not necessarily in your packet, but just watch how I look at these tables and decide. I'm going to go through this example 3, 5, and then 6. We'll do one of each. First of all, when you look at a table, remember it's input and output. The output are the y values. And that's really what you're going to focus on. Just double check and make sure that your x values are going up evenly. Like for example, in number 3, these are all going up by 1. And if we look at how our y values are changing, it looks like we're adding 2, or no, we're subtracting. We're subtracting 2 each time. So let's subtract 2, subtract 2, subtract 2. If you add or subtract, that means that the function is going to be linear. That negative 2 will end up representing your slope. And so since this 5 is the y-intercept, we'll get y equals negative 2x plus 5. In this particular section, we are only going to focus on is it linear, quadratic, or exponential. I'm not going to ask you to write the equation. I do want you to recognize a linear equation that would just have an x, no exponent at all. So be able to recognize it from the equation, from the table, and then of course if you look at a graph, make sure you can tell if a graph is linear. If you look at number 5, this time the first set of points moves down 6, then it moves down 4, and then it moves down 2. So it's certainly not linear. But if we do that one more time, you can see on the second change, it's moving up 2 both times. If you get a consistent addition or subtraction on the second change, then that is a quadratic. So from a table, it looks at first like you're just going to be subtracting or adding different numbers, but then the second time you look at the difference, it'll be consistent, and that's how you know it's quadratic. Of course, you would see parabolas for the graphs, and on the equations you would see an x squared as the highest exponent. On number 6, what's happening each time, we're not adding or subtracting, this time we're dividing. We're dividing by 5. If you multiply or divide for your y values, that is going to be exponential. And of course, in the equation, you're going to see, let's see, this will be 5x in the exponent. You'll see the x in the exponent. And the graph will look like the J curve. This is division, so you'll end up getting a decay. But you should recognize the growth or decay curves from the graphs. One other thing that I wanted to tell you about quadratics, another easy way to tell if it's quadratic, sometimes the charts will have the symmetry. So for example, if I make a quick XY chart, and let's say I have negative 1, no, let's do negative 2, negative 1, 0, 1, and 2. And let's say I have 4, 2 on either side, and negative 3 on either side. And you see that symmetry that happens on your y values, then that will also be a clue that it's quadratic. The particular example I chose did not have the symmetry, so it wasn't so obvious. But if you see symmetry on both sides of the y values, then it's definitely going to be quadratic. So once again, for the tables, like number 3, you add or subtract, it's linear. For number 5, for a quadratic, you'll either see symmetry or you'll see the second tier change. And then on number 6, it's exponential because you see the multiplication or division.